we will take nodes from this list to be processed, and we will keep checking their neighbors. So we'll start a loop for each in to be processed if each not in processed node. So if this node has not already been processed, if each not in processed nodes, then we will look at its neighbors. So let's have this list. Na is equal to g dot neighbors. We have to look at the neighbors of each, so we'll write like this. Now we have to see, we have to take these neighbors one by one, and we have to see whether these neighbors are friends or enemies. If they are friends, they will be added to the first list. If they are enemies, they will be added to the second list. Apart from that, if they are friends and they are being added to the first list, they have to be processed afterwards. So they will be added to the list to be processed. And if they are enemies and they are being added to the second list, then they will not be processed further, so they will be added to the list process nodes. So we'll write for I in range length of this list, because to get to know how many neighbors are there. Of course, in this particular example there are n-1 precisely n-1 neighbors, but we can generalize this and we can write up to length of neighbors. So once we take the neighbor, we have to check the relationship of this neighbor with the node, that is each. So we will write g each to na of I. And how do we check the relation? By using this attribute sign. So we'll start this if this is equal to plus, which means it's a friend. As I told you, what has to be done? It has to be added to the list of first coalition. So if it is not already there, so we'll check if na I not in first coalition, then it will be added there. So we'll write first coalition dot append na I. Done. And second thing that has to be done is it has to be added to the list of to be processed nodes if it is not already there. So write if na I not in to be processed, then it will append it there. To be processed dot append na I. Alright. And in the other case, when the neighbor is an enemy, what we are going to do is, so we'll write elif and this thing, which means this is minus, so it's an enemy. What has to be done? It has to be added to the second coalition list if it is not already there. So we'll write if na I not in second coalition, it will be appended na of I. Okay. Second thing that has to be done is, as I told you, it doesn't have to be processed again, so it has to be added to the list of processed nodes. So we can directly just add it there, processed nodes dot append na of I. Next thing that has to be done is this each, the node which is called each has been processed now, so it has to be added to the list of processed nodes. So we'll write here process nodes dot append each. Okay, so that is done. So this loop should basically divide the nodes into two lists, that is first coalition and second coalition, and that is what this function will return. So we are going to return this. So we'll write return first coalition comma second coalition. Okay, this should work. Let's go down and see. This is where we called this function, and after it returned the two lists, we are just printing those two lists. So let's see how it works. Okay, these are the 8 cities, and you see the relationships amongst them as well, positive and negative relationships. I'm closing it, so it has processed, and you see these are the two coalitions formed. In the first one there are 5 countries, and in the second one there are 3 countries. So this is the division. In the next video we are going to visualize this network, and we are going to compare it with the initial configuration that was entered initially.